Chapter 2 Sample Test says differentiate this. So if I want to find dy dx, in the big picture I see a quotient rule. So I'm going to set up the quotient rule. So that's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. Derivative of the numerator times the denominator, so I'm going to put that in because I don't have to take the derivative there, 2x squared minus 3x. Derivative of the denominator times the numerator, so I'm going to put in the 5 square root of 3x over the denominator, quantity squared. Now let's look at the derivative of the numerator. So the numerator is 5 times 3 to the 3x to the 1/2. So there's chain rule involved in here. So the derivative of this would equal, the 5 is a constant, so and it's times, so it hangs on. Derivative of the inside, derivative of 3x is 3. And then the derivative of the bigger picture is 3x to the 1/2, and so it would be 1/2 using the power rule, and 1 less than 1/2 is minus 1/2, which would be, see, 15 divided by 2, and then the negative would put that in the denominator, so that'd be 3x to the 1/2 in the denominator of that. So I'm going to put in here, for the derivative of the numerator, 15 over 2 times the square root of 3x. Now the derivative of the denominator looks like it's just the sum rule for derivatives. So the derivative of this, the constant will hang around, and that'll be times derivative of x squared is 2x times 2 is 4x, and the derivative of minus 3x is minus 3. That's a sum. We've got some addition and subtraction, so I need to put parentheses. So there is number 1. Number 2. So f of x equals tangent squared, but I'm going to make it look more like a power rule, of x squared squared. So I see in this, hopefully you see it also, 3 layers. The inside is an x squared. Then we have the tangent of that. And then we have that quantity squared. So f prime of x, if I look at the derivative of x squared, that's 2x. Now the derivative of tangent of something will be secant squared of that something. And then the derivative of something squared is 2 times that something. To the 1. So there's f prime of x. And then it says determine whether it's increasing or decreasing at negative 1. So we're going to find f prime of negative 1. Now, I suggest, since you're putting in a negative, and people often forget that if you, let me demonstrate this here. If we type in negative 1 squared, the calculator is going to say it's negative 1, which is correct because the negative is not getting squared. To actually square negative 1, you have to go parenthesis, negative 1, close parenthesis, squared, and then you'll get the true value, 1. So when you're putting negative 1 into places like that or that, you have to have another set of parentheses just to keep that done correctly. Or the alternative is, well, let's do that. So that's going to be, let me see, push this over a little bit. So I want to do 2 parenthesis, negative 1, close parenthesis, secant squared. Now secant squared, that's secant to the 2, whole quantity to the 2 power, but secant is 1 over cosine, so I can do cosine to the negative 2 power, cosine of negative 1 squared. So I have to go parenthesis, negative 1, close parenthesis, so I get all of negative 1 squared, and then close the cosine, and then I have to square that whole thing, so the cosine of this. So I really technically should put in a cosine parenthesis here, not a cosine, but a parenthesis, so that I could say this whole quantity squared, but I don't want it squared, I want it to the negative 2, so that it's secant. And then I have times 2, and then I have tangent, and again I have a negative 1 squared, so I need to do a parenthesis to get the negative 1 attached to itself and square that, and then close the tangent. And if my mode is in radians, it is, I should get the answer of the correct answer, which is negative 21.339. And so it's negative, so it must be decreasing. And we can check that. So I'm going to go back and type in the y equals, I'm going to type in tangent of x squared, close that, and that whole thing. So I should probably go back. I don't think I have to, but I'll try it here. I'll try this, and then I'll try it. Let's see if we get different here. I'm going to go parenthesis, tangent of x squared, close a parenthesis, the whole thing squared. Oop, squared. I think these will come out the same. Let's see. We'll graph on Zoom trig 7. There's the first one, and the second one's doing the same. So I don't need to. So I'm going to stop it, and I'm going to go to y equals, and I'm going to delete this one. And then I'm going to push the graph again. I want to know what's going on at negative 1. Well, let's go zoom in, zoom to, enter. At negative 1, looks like the slope is positive at negative 1, doesn't it? Second, calculate the slope, dy dx, at negative 1. No, it says it's negative 21.34. And it's off the top of the screen, so I'm curious. I'm going to go look at it a little closer. Oh, maybe that's not -1 if I'm in Zoom Trig. Let's go to Window, and let's make the X scale be by mark it off every 1 and not every pi over 2. So now let's go back to the graph. Now it's showing us where -1 is, and that does look like it's going downhill. Let's look a little higher here. Let's look at the y max. Let's make it be 4 or so. Graph. And now let's go second. Calculate the derivative at -1. And there you can see that it's going downhill negative. The mark looked like -1 was further over, but that was because it was marking at pi over 2 when you do Zoom Trig. Okay? Zoom Decimal probably would have got us there better. Now it's at -1's right there, and we can go second, calculate the derivative at -1. And we can see it's negative 21.34. Okay? Number 3. This one requires implicit differentiation. So we have x, y equals sine of y. So here we have a product. So we have to do the product rule. Equals, over here we have just sine of y. But that's a function inside a function. It's not sine of x, it's sine of y. So we have chain rule. So we've got the derivative of the inside times the bigger picture. So let's go to the product rule. That's the derivative of the first times the second plus the derivative of the second. Now the derivative of y is dy dx times the first. And then over here, the derivative of y is dy dx. And then we have times the bigger picture, sine of something. The sine of something is cosine of the something. Okay, so here's the equation. Now, the slope is dy dx. So let's see if we can solve for dy dx. Let's bring the dyx term over with the other dy dx term. So I'll have 1 times y, or y equals dy dx times the cosine of y minus dy dx times x. I have dy dx in both of these, so I can factor it out. Times cosine y minus x. Okay? So then if I divide by cosine y minus x, I get y divided by cosine y minus x equals dy dx. So I looked at this thing, and it's times this. So it's equal to y, so I divided both sides by that and got dy dx, that one that would be left like that. So now, what's the slope at pi over 2? So that would be dy dx evaluated at y equal pi over 2. So what's x equal to? So I need to put pi over 2 in for the y's and figure out what x is. So x would times y equals sine of y. So this says x times pi over 2 equals, the sine of pi over 2 is 1. So if I divide both sides by pi over 2, I get x equals 1 divided by pi over 2, or 2 over pi. So that's the x coordinate. X equals 2 over pi. So the slope would be y over cosine of y. Cosine of pi over 2 is 0 minus x, which is minus 2 over pi. So I got 0 minus 2 over pi. And so if I multiply by the reciprocal of the denominator, pi over 2, pi over 2, and the minus would come up. It's minus this fraction. And I get pi squared over 4. Now, if you take Desmos and graph this, it doesn't quite give you the correct graph, but I'm going to tell you what the correct graph looks like. If y was 0, sine of 0 is 0, so 0 would equal 0. So anytime y is 0, this graph, this equation is true, which would be all of those values. That's where y is equal to 0. Otherwise, it looks something like this. So it has this plus this graph both. And if we're looking at 1, the slope is something right here. It's negative, and 3 squared is like 9/4, which is 2 1/4-ish negative. Something like that. Let's see what it really is. Second quit. Pi squared divided by 4. It's negative 2.467. Find it. So that's the slope of the tangent line, negative 2.467, or negative pi squared over 4. You notice that I can take the derivative and get it, but I also define what the value of the slope is. I need to know x and y, so I had to use this value for y and figure out what the x is for the point. This point here that we're looking at is 2 over pi in the x and pi over 2 in the y. Okay? This is how I found the x here, and that's that part. Okay, number 3. So determine whether y is increasing or decreasing at 1. So dy dx is going to equal. All right, what do we have here? Well, it looks like I have a product. So I'm going to set up the product. And it's the derivative of the first times the second. So I'm just going to write that in. Cosine inverse of x. And then the derivative of the second times the first. I'm going to write that in. Now, the derivative of the first, d e to the minus x squared dx, I see chain rule in that. I have minus x squared. The derivative of that is the inside of the e to the something formula, so that's going to be minus 2x to the 1 times the derivative of the bigger picture. Derivative of e to something is e to the something. So that's the derivative of the first, minus 2x e to the minus x squared. And then the derivative of the second. The derivative of cosine inverse of x, not the reciprocal, so it's not the secant dx, is 1 over the square root of 1 minus x squared and negative. And now I got to put in a plus 1. Plus 1 is fairly easy to do. So I'm going to have dy dx, and I don't have to solve for y because this all has all x's. Unlike this one, I have x's and y's in the derivative. So I just got to put it in. So negative 2 times 1 is negative 2. E to the 1 squared is 1. This negative is not inside the square. So 1 squared is 1 times a negative. So that's negative 1. So that's 1 over e times the cosine inverse of 1. So cosine, that's saying what angle has a value cosine of 1. And that, I believe, is 0. Let's confirm that. So what angle has a cosine value of 1? So we're going cosine inverse of 1, and we should get 0. The 0 radian or 0 degree angle has a cosine value of 1. So this is times 0. So that all is gone. Plus, if I put 1 in here, 1 squared is 1. 1 minus 1 is 0. So I have undefined times 1 over e, because that's what that is. So we have 0 for this part and undefined but here, so this does not exist. This can't calculate the slope at 1. Let's take a look at y. So let's go here and we go e, clear, e to the negative x squared cosine inverse of x. And, I didn't go down. Didn't go down. Fine. Cosine, not cosine, cosine inverse of x. Close parentheses. Graph. And the graph disappears at 1. Now, if I asked you for half or some other one, I could do it, but it disappears at 1. Now, if we just look at the pieces, let's go to e to the negative x squared, graph that. That exists all along there, so that's there's no problem with that. But let's look at now second cosine. Down here, let's look at the cosine inverse. Cosine inverse of x, and push graph. You see how the cosine inverse ends at 1. If it ends at 1, you cannot find the derivative because that would be not, it would not have a right-hand limit. So that's why we're getting no slope there. Okay? Now let's go to this one. Is this differentiable over the interval -1 to 1. Well, let's take a look at those. So go back here and clear and clear and clear and go to 2 to the minus x, 2 to the negative x graph. So that looks like it exists for all x's negative and positive. So that's not going to, that'll be differentiable. Now let's look at ln x. Y equals ln x. Ooh, that doesn't work at 0 or smaller. It'll work from greater than 0, but not anything smaller. So is it differentiable over that interval? No, it's only differentiable from 0, not including 0, to 1 on that interval. It's actually integratable from 0 to infinity, not including 0. So determine the equation of the tangent line at point 5. Well, we can do that because it is integratable, differentiable on that range. So let's now find the equation of the tangent line. So we're going to write f prime of x and find the derivative. And this looks like a sum. This has chain rule. Derivative of negative x is -1 times the derivative of 2 to the negative x. So you do the ln of the base times 2 to the negative x. That's the derivative of that one, minus derivative of ln of x is 1 over x. Now if we're doing f prime at 0.5, we would have negative ln of 2 times times 2 to the negative of, oh, what am I doing here? ln 2, oh, that's the first place I'm putting an x, and that's a 0.5, so negative 0.5 minus 1 over 0.5. So I've got to do negative ln of 2, close parenthesis, times 2 to the negative 0.5, come down. If you're doing it on a different calculator, you might have to put that number in parentheses, minus 1 divided by 0.5, which is 2, but I'll write it that way. And I get negative, so f prime of 0.5 is negative 2.49. Okay, oop, that's out of your screen, sorry, that slipped up there. Okay, hopefully not all of that was out of your view. So, took the derivative of the exponent, derivative of negative x is -1, ln of the base times 2 to that, ln 2 to the negative x, derivative, big picture is -2 to the negative x. Derivative of ln is 1 over x. And I put in 0.5, got that. The tangent line, though, that's L of x thing, and we're doing it at a equals 0.5, and so we're going to go the derivative at 0.5, which is negative 2.49 x minus a. plus f of a. So I got to put 0.5 into the original function. So I need to figure out, actually I'm going to type it in here. This is the way I like to do it. 2 to the minus x minus ln x, close parenthesis. That's the original function. Let's just get rid of that one. And go to table. I could just plug, let's see, table set, go to ask, check the table, and put in, we got to find it at 0.5, and it's 1.4003. Okay, now I'm going to graph that function on zoom 4. That's what that looks like. And then I'm going to graph my tangent line, and it's supposed to be tangent at 0.5. 0.5 is right there, about there. So let's try graphing that. So go to the y equals and go negative 2.49 parenthesis x minus 0.5 close parenthesis plus 1.4003. Let's see if that looks like a tangent line at a half. Let's see, I can actually second calculate the intersection between the blue equation. First curve is, well, I got to move over on it. There's in the blue curve. There's the second curve, and my guess 0.2 is okay, and it says they intersect at 0.495. That, yep, that's close to 0.5. Their estimation. Okay. All right, so there's the equation of the tangent line they asked us to do. Okay, this one. The object is thrown straight up at 75 feet per second from a height of 100 feet. So the height is given by this. Starting height, starting speed, and acceleration due to half of the acceleration due to gravity. Determine the velocity equation. Velocity of function of time is the derivative of the height equation. And that would be, see, 2 times negative 16 is negative 32t. Derivative of that is plus 75. What is the acceleration equation? Well, the acceleration is the derivative of the velocity equation, which is the second derivative of the height equation, which would be the derivative of this, which is negative 32. Then what is the velocity at 2 seconds? So I put 2 into this equation, and I'm going to get negative 32 times 2 plus 75. So that's negative 64 plus 75, which is 11 and feet. This is velocity per second. Make sure you put your units up. Okay? And this one. Determine the derivative of f of g of x. F of g of x, the derivative of that, dx. This is chain rule, so it's the derivative of the, excuse me, derivative of the inside times the derivative of the bigger picture, f of g of x. Okay, f prime of g of x. Okay, and we're doing this at 1.14. So at x equal 1.4, we're going to be finding g prime of 1.4 times f prime of g of 1.4. Now, g of 1.4 is 0.7. So we're finding g prime at 1.4 times f prime at 0.7, and 1.4 g prime would be the slope there. So using central difference, it would be 60.67 minus, making sure that you can see that, minus 0.74 over 1.5 minus 1.3. And f prime at 0.7, so we have to go up here, and that would be 1.11 minus 1.43 over 0.8 minus 0.6. So we get, that's 0.07 divided by 0.2 times 32, negative 0.32 divided by 0.2. I'm going to quickly check my mental arithmetic here. 1.11 minus 1.43, because I don't want to make a mistake, negative 0.32. So I have 0.07 divided by 0.2 times negative 0.32 divided by 0.2, and I get negative 0.56. I don't give you any units. That's all you can do. Okay? Now, I could have made this a graph, and you'd have to do it from the graph and estimate slopes and that kind of thing, or the table. So be aware that it could be a graph.